Good afternoon to you all, Mindsetters. This is your favorite show, Learn Extra Live with me, AB. And of course, it is a Monday, a Triple M day, which we call a Mindsetters Maths Monday. I'm not alone. I'm with my favorite teacher ever, who's doing maths the way I like, Natasha. Natasha, how are you?
I'm sure you said that to all the teachers, but I feel very special.
No, I don't. Trust me. Trust me. I'm saying this on camera. I'm not lying.
Okay. All
How
right,
are
well,
you?
it's great to be here, Abram, and it's great to see you.
Thank you very much. How was your weekend?
It was fantastic, and I'm glad that I'm here for your Triple M Monday.
Nice one. Mine was very busy. But otherwise, what are we doing today?
All right, Mindsetters, so today we're looking at trigonometry. We're going to go over quite a lot of stuff that you have done already in the year and bring you up to date with everything. So sort of putting all the trig you've done in the year, putting it all together in one lesson, summarizing.
Nice one. I like that one. Now, things that I need to tell you, Mindsetters, is that as my weekend was very busy, on Saturday I got to see some of the Mindsetters at the CR SWAT School in Pretoria North. So to all the Mindsetters that were there, a big shout out to you. But otherwise, for today's show, you need to interact with me on Facebook, like our page if you haven't. And also, if you have, chat on the page, ask some questions. Our Facebook page is facebook.com/LearnExtra. The second thing that you need to do is to follow us on Twitter at LearnExtra. And lastly, download your notes all for free on learnextra.co.za/live. Let's get talking. I'll also post some fast link of those notes on our Facebook page. But for now, let's all get into learning.
All right, guys, so as I said, today we're going to summarize, cover everything you've done in trig so far this year. So we've got quite a lot to cover. I'm sure if you've already gotten to the end of trig, you know that there's quite a lot of work that we still have to do. Okay, well, in today's lesson anyway. We're going to look at two-dimensional problems. We're also going to have a look at trig ratios on a Cartesian plane, and then hopefully we'll have enough time at the end to look at a bit of trig functions. Now, trig is one of the sections where there are so many real-life applications. You know, people always say, well, what are you going to do with this in maths? What are you going to do with that in maths? Well, trig is one of those sections that you use all the time. It's everywhere. You see it all the time. So what I want to do firstly is look at some of the real-life applications of trigonometry. So let's have a look at that. All right, so trigonometry is commonly used to find the height of towers and mountains. It is also used in navigation, so we can use trig in navigation. We can use it to find heights. In navigation, we use it to find the distance of the shore from a point on the sea, among other things. All right. It can also be used in oceanography. Okay, so oceanography. And that you use to calculate the heights of the tides in oceans. All right, so similarly, you'll see we have a little diagram there of how it is used in oceanography. We also use trig to find the distance between celestial bodies. Okay, so to find the distance between different planets and that, we can use trig, or we do use trig in everyday applications. Okay, so we've got quite a lot of all of this to cover. You know, eventually, if one day you become an oceanographer or you become a navigator, or something like that, a pilot, you're going to be using trig. So it is an extremely important section, and it is something where I think when we're just looking at it in terms of exams, it's a place where you can get lots and lots of easy marks. Okay, so let's have a look at our first question for today's lesson. All right. And here we're using trig to find the distance and heights of objects. So here we are told that a ladder of length 15 meters, so they tell us that the length is 15 meters, is resting against a wall. The base of the ladder is 5 meters from the wall, and they ask you to find the angle between the wall and the ladder. So obviously, to do this, the first thing we need to do is actually draw a diagram, because without a diagram we can't really see what's happening. Okay, so we have a wall, okay, and then you have a ladder that's resting against that wall. So that's our ladder there. They tell you that the height, or the length of the ladder is 15 minutes, but also the distance from the wall to the ladder, so from there to there, they tell you that that's 5 meters. So let's fill in the information that we have from each of these bits of information. We know that this is going to be 5 meters, right? That's the distance of the ladder from the wall. Obviously, the wall is at 90 degrees. Now, why is that obvious? Well, because a wall will be perpendicular. If it's not perpendicular to the ground, it will be leaning. Okay, so a wall has to be perpendicular to the ground. So, therefore, the angle between the wall and the ground is 90 degrees. We know that the ladder is 15. All right, and that's all the information they gave us. They then ask us to find the angle between the wall and the ladder, so we will call that angle theta. Okay, so that's the angle that we're looking for. All right, so do we have enough information? Yes, we do. Okay, so here we're going to use our trig triangles, and you would have done your Pythagoras ratios, you know the definition of sine, cos, tan, and all the rest of them. So we're going to now use all of that and apply it to this problem. Okay, so we're looking for the angle theta. What have we been given? Remember, if we take it from the angle theta, the side opposite that, all right, so that one, the opposite side is 5 meters, and then the hypotenuse is 15. So we know that the hypotenuse is 15, and the side opposite theta is obviously your opposite side. So now you've got to think about, well, what ratio is opposite over hypotenuse? What ratio is that? Okay? And if we have a look at opposite over hypotenuse, that's the ratio for sine of theta. Sine of theta is opposite over hypotenuse. Okay, if we were given the adjacent side, then we'd have cos of theta is adjacent over hypotenuse, and our definition of tan of theta, since we're writing all of them down, is opposite over adjacent. Okay, so we look at what we're given, we see that we've got the opposite, we've got the hypotenuse, so we need to use sine of theta. So we set it up and we say, well, sine of theta is equal to opposite over hypotenuse. So it's going to be 5 over 15. We can simplify that to a third if you like, because 5 goes into itself once, 5 goes into 15 3 times. All right. So if I'm looking for theta, guys, remember, if you're looking for your angle on your calculator, you need to start with the shift button. So I want to say, what is my angle when my ratio is a third? So I go shift sine of 1 over 3. And we get an answer of 19,47 degrees. So therefore, what that means is that the angle theta that the wall makes with the ladder, this angle here, is 19,47 degrees. Okay, and that's really just a very straightforward, simple application of how we can use our trig functions and definitions to find an angle. All right, let's look at another example. Okay, so here this one is maybe a little bit more complicated, but it's more of looking at how do we find angles. So we looked at one where we actually had to draw the question. Now what happens when they give you the diagram, there's more than one triangle involved. How do we find an angle in that case? All right, so let's have a look at what we've got in our drawing. We've got triangle ABD. They've asked us to find angle ABC, which we'll call alpha this time. All right, and as you can see, we've got more than one triangle. We've got triangle ABC, we've got triangle ABD, and we've also got triangle ACD. So there's quite a few triangles to work in, but we are looking for angle B or angle alpha. So how do we go about it? Well, always with your 2D problems, we're going to start in the triangle with the most information. In this case, that happens to be triangle ADC. Okay, why do I want to start there? Well, if we're looking for alpha, right, and we look in triangle ABC, the only thing we have is the opposite side. So that's not really going to help us, because if we're trying to find an angle, so if we're looking for an angle, right, and we're using our basic definitions of our trig ratios, we need to have two sides. You have to be given two sides to find an angle in a 90-degree triangle. All right. So if we look at triangle ABC, well, we've only got one side. Then if we look at the big one, ABD, there's similar problem. All we've got is BD. So how do we find alpha? Like I said to you, we need to work in the triangle with the most information. So we work in triangle ADC. How is that triangle going to help us? Well, guys, you'll see that if you look at triangle ADC, you have an angle and you have a side. All right, so you have the opposite side, you have the angle, and we know that in the big triangle ABD, we've got that side DB is actually 17. So now if I knew what this is, what side DC is, then all I would do is simply subtract side DC from 17, and that will give me BC. Okay, because remember, BC plus DC will give us the side BD. So obviously, if we know that BD is 17, right, and we work out what DC is, then we simply subtract to get BC. All right, so we're going to work in triangle ADC. Okay, so in triangle ADC, we've got the angle 41 degrees. Remember that AC is perpendicular to DB, so therefore this angle DCA is also 90 degrees. So I've got the opposite side, and I'm looking for DC, which is the adjacent side. So I say in triangle ADC, tan of 41. Why tan? Because tan is opposite over adjacent. So tan of 41 will be equal to AC over DC. But we know that AC is in fact 9. So if I'm looking for DC, what I need to do is to cross multiply. Okay, so we cross multiply to bring DC to the numerator. So we'll get DC times tan 41 is equal to 9. All right. We're looking for DC, so we need to divide both sides by tan 41. So DC will be 9 divided by tan of 41. And that's going to give us, let's have a look, 9 divided by tan 41. And that gives us 10,35. All right. So now that we know that DC is 10,35, we can work out BC, because BC is simply going to be, let's just go back to our question there, BC is simply going to be 17 minus 10,35. So BC, 17 minus 10.35, and that's going to give us, let's have a look, so it's 17 minus that, and we get 6,65. Alright, so BC is 6,65. So now that we've filled that in, guys, have a look at the diagram and see what we've got. I'm just going to raise that so it makes it a little bit easier for you to see. We know that BC is 6,65. We know that AC is 9. So in triangle ABC, I can work out alpha because we now have the opposite side and we have the adjacent side. So you can see that in triangle ABC, you now have two sides. So we've got two sides. in our 90-degree triangle, that means we can use our trig ratios and work out the angle alpha. All right, so let's quickly do that. I think we should quickly finish this question before we take a quick break, Abraham. I know that you want to go for a break, but guys, we're going to quickly finish this off. It's going to take 1 second. So we're going to rewrite this and say, well, tan of alpha is going to be opposite, which is 9, over adjacent, which is 6,65. So therefore, I use my calculator and work out alpha. All right, remember we're working out an angle, so we start with shift, and our ratio here is tan, and we've got 9 divided by 6.65, and that gives us an answer of 53,54. All right, so therefore we've worked out alpha using the two sides that we have in that triangle. And as I promised, it was a really quick, short things left to do in that question. Hope you all understand. And if you don't, then I'm sure Abraham is waiting for your questions during the break.
Indeed. Thank you very much, Natasha. And also to all the mindsetters that started their trial today, let us know how was the paper. And to all those that are going to be writing this week, all the best. We're wishing you nothing else but the best. Hence, we're giving you tools that are there to help you. But for now, don't move. We'll see you after the break. Welcome back, Mindsetters. Now, I told you that my weekend was very busy, so I met some Mindsetters at the CR SWAT School in Pretoria North. I have an album posted on our Facebook page with the pictures. Check yourself on that and let us know how has a mindset changed your life also on that day through the presentations that we had. But for now, Natasha, I have a very simple question for you, which is just to help the Mindsetters that are confused about this trick that we're doing now. Didn't we do this in first term?
Yes, guys, as I said in the beginning of today's lesson, today is basically revision of all the trig you've done so far. So we're going to try and cover all the little bits, the two-dimensional trig, trig on a Cartesian plane, and trig function. So well spotted, it is something that you would have done before, but as we're getting closer and closer to exams, it's a very good idea to revise.
All right, thank you.
All right, so on that note of revision, we're going to carry on with trig, and now we're looking at trig on a Cartesian plane. All right, so let's have a look at our first question in this section. So we are given a point, P, which is -3, 4. They tell us that that's a point on the Cartesian plane. Angle XOP is equal to theta, and X is a point on the x-axis. Without using a calculator, and that's very important because when they say without using a calculator, you're obviously going to get no marks if you do use a calculator. And they say determine the value of, and they give you A, B, C. All right, so very important, guys. In this section, you'll say, but how am I going to use a calculator? I need to work out fractions. Yes, if you need to add your fractions and that on your calculator, you can. But if you're going to try and work out the value of theta, and then plug that value of theta in to give answers and ratios for each of these questions, you're not going to get any marks because that's not how we want you to approach this kind of question. So how do we want you to do it? Well, I'm going to show you now. All right, so we've got P that's given as -3, 4, and we know that XOP is equal to theta. So we're going to draw a diagram. Remember, it's on the Cartesian plane. So let's first draw our Cartesian plane. Okay, and they tell you that the point P is -3 and 4. So -3, 4, that's going to land you in the second quadrant. So X is -3. All right, so we're going to say that's somewhere there, and Y is 4. We're going to call that point P. And I'm just going to draw a line from the origin to that point P. Okay, so that's what our diagram's looking like so far. That point here, the blue point, is point P. They tell you that XOP, so this is your x-axis, remember, XOP is equal to theta, so that's your angle there. And without using a calculator, determine the value. So without using a calculator, we need to drop a perpendicular from the point P to the x-axis. So that's going to be 90 degrees with the x-axis and the line from point P, so from your ray. All right. And we know that P has coordinates -3, 4. So that tells us that the x distance in this triangle that we've drawn, that's 3 units. Okay. And then your y distance to that point P is going to be 4 units. All right. The first thing we should do before we even try to answer these questions, guys, is to first work out the length of the radius. So we need to work out OP. And because we got this Pythagoras triangle, we just use Pythagoras. So we can say, well, x squared plus y squared is equal to r squared in that triangle. We know that x is 3. We know that y is 4. Alright, so we're simply going to simplify. So we get 9 plus 16 is equal to r squared. Therefore, r is going to be the square root of 25. Alright, and the square root we're interested in is the positive square root because our radius, it's a length, it will never be negative. So therefore, the radius is just 5 units. Okay, so that distance OP is 5 units. So once you've now drawn this diagram, okay, so you've got your ray in the second quadrant, we've dropped a perpendicular from that point P to the x-axis, and we've got the distance of the x, the y, and the radius, we can now answer the questions. Okay, so the first one says, find cos of theta. We're going to go straight to our diagram and read it off. So cos of theta is, if you're using, guys, and let me show you this, I've shown this to you before, but if we're using x, y, and r, x is the same as adjacent, y is the same as opposite, and r is the same as hypotenuse. Why do I bring that up? Because some people only remember it as cos is adjacent over hypotenuse, but they correspond in this way. Okay, so if you know that cos is adjacent over hypotenuse, a is the same as x, so therefore this would be x over hypotenuse is the same as r, so it will be x over r. Okay, and it works in the same way for sine and for tan. So cos is x over r, so I go to my diagram and I say that's going to be x is 3, r is 5, so cos will be 3 over 5. Alright, next one, part B, we asked to find 3 tan theta. So tan we know, again using our diagram, tan is y over x, so y over x, or opposite over adjacent, so it's going to be 4 over 3, and we simplify that, the 3's cancel, so we just left with 4. And then the last one, they ask us for a half of cosec theta. So a half cosec theta. So here we've got the reciprocal ratio. Okay, now you would have seen this before. Cosec is actually the reciprocal of sine. So sine of theta is y over r. So cosec is going to be the inverse of that. It's going to be r over y. Let me quickly remind you while we're on this point of your reciprocal ratios. Alright, so cosec we know is the same as 1 over sine. So cosec is 1 over sine theta. Sec of theta is 1 over cos theta, and cot of theta is 1 over tan theta. Alright, so it means that if sine is, well, since sine is y over r, to find cosec, I simply invert that ratio. So therefore cosec of theta is going to be equal to r over y. Alright, so that means when we go to our diagram, we now take the ratio for r, which is 5, over y, which is 4. Okay, and that's going to give me 5 over 8 when you simplify. Okay. Alright, so this is a really, really important section. You're going to get asked a question like this. Chances are you will get asked a question like this. We love testing that you understand how to do trig without using a calculator on the Cartesian plane, where you've got to draw the diagram. It's such an important section that I want us to do another question on this section. Alright, so this is question 4. Here we are given that sine of theta is equal to 0,4. Theta is an obtuse angle. Now remember, what does obtuse mean? Obtuse, greater than 90, less than 180. So if I draw it, it's going to end up in quadrant 2. Okay, so theta is an obtuse angle, and then they then ask you to find cos of theta and then root 21 tan theta. Now guys, this one is slightly different because if you look at sine theta, it's not apparent immediately that you need to use a Cartesian plane and you need to draw a Pythagoras triangle. So a lot of people mistakenly will say sine of theta is 0,4 and then use their calculator and work out theta. So be careful, hey? Because these kind of questions are always without a calculator. So how do we do it without a calculator? We say, well, sine of theta is 0,4. Another way to write 0,4 is 4 over 10. Why do I want it in that form? Well, when it's in this form, then I can make a ratio out of it. I can say it's y over r. Okay. I want to simplify that a little bit. 4 over 10 is the same as 2 over 5, because 2 goes into 4 twice, 2 goes into 10 5 times. So this is now the ratio for y over r. Once it's in this form of sine of theta equal to a fraction, we can then draw a diagram. Now importantly, they told you that theta is an obtuse angle. Sine of theta is 0,4. Now the reason they had to tell you that is because remember, sine of theta is positive in the first quadrant and the second quadrant. But the fact that they told you it's an obtuse angle means that it has to lie in the second quadrant. Okay, so our diagram is going to fall in the second quadrant. It's going to be perpendicular to the x-axis. This is our angle theta. Alright, and we know that sine is y over r, so y is 2, opposite over a hypotenuse, and your radius or your hypotenuse is 5. Before you try and answer your questions, first work out the value for x using Pythagoras. So we're simply going to say, well, x squared plus y squared is equal to r squared. We know what y is, we know what r is, so therefore x squared is going to be r squared minus y squared. Alright, so it's going to be 25 minus 4, which is 21. So therefore x is going to be plus or minus the square root of 21. Now guys, here you've got to be careful because x can be the positive square root or the negative square root. However, you're on the left hand side of the y-axis. So therefore you're in the second quadrant, so therefore all your x values are negative. So therefore x will be negative root 21. So the x value, the x coordinate at that point will be negative root 21. Okay, now that we've got that, now that we've got the x value, we know the y and the r, we can answer cos of theta. We simply go to our diagram, we say cos is adjacent over hypotenuse, or x over r, so it's going to be negative root 21 over 5. It's just simple reading it off the diagram once we've interpreted that they want us to use this diagram. Alright, then part B, root 21 of tan theta. We know that tan is y over x, opposite over adjacent. So it's going to be 2 over negative root 21 right? So here we're going to have root 21 cancelling in the numerator with the denominator of the fraction. So our answer is just going to be negative 2. Alright. Okay, so hopefully that you're all with me, you all understand this section very well now. As I say, if you are asked to do this question, you need to do it without a calculator. So make sure you understand how to apply, how to use all the rules that are necessary to do this question. Abraham, do we have any other questions from the mindsetters?
So far, based on that question, we don't have one, but we had one from question 2, which was quite a challenging one, and then I've put it to the mindsetters on the page to give us their own view. The first question was, why did we have to find DC instead of AC on question 2? And a second question based on question 2 was, why did we find DC before we could find BC?
Why did we find DC before we could find?
BC.
BC.
Yes.
Okay. Okay. So let's answer the first part of that, which
the
is
first one is, why did we have to find DC instead of AC?
Okay, AC was given as 9. So therefore, you obviously can't find AC because they gave it to you. So you're not going to look for AC, because if I take off everything that we have here, you will see that AC was actually given to you. So there's no way that you can do this question by trying to work out AC because it was given to you guys. Why did we go for DC and work DC out first? Because remember, we always work in the triangle with most information. If you try and work in triangle ABC, there's actually nothing that you can do, because all you've got is one side. You don't know what that is. You don't know what BC is. You don't know what AB is. And you don't know what angle B is, you don't know what angle A is, so there's not enough information to work in triangle ABC and to work out side BC first. Okay, so we had to work where there was more information, which is triangle ADC, because we had an angle and a side, and therefore we could work out DC, subtract DC from DB, and that will give us BC.
Thank you so much, and thanks to the mindsetters such as Apiwe, Claudia, Spume, and Diketso who have answered that on our Facebook page, and they got it right. So mindsetters, don't move wherever you are. We'll see you after the break. Welcome back, mindsetters. Now they say it is always good to dream, but in your dreaming, always plan and act. So to all the mindsetters that are about to write their exams and that are writing their exams, dream, plan, and act after all. So for now, let's continue, Natasha.
All right, guys. Okay, so for our last question for today, we're looking at trig functions. Remember, we're revising trig today. We've looked at a few basic two-dimensional problems. We've looked at trig on a Cartesian plane, and now lastly we're going to look at trig functions. Okay, what I really want to do in this part of the section is show you how to use your calculator to plot the points. Okay, so the main thing that I want to get across to you right now is how do I use my calculator to work out the points so that all we simply have to do is plot them. Okay, so this one we are asked to sketch y is equal to negative 4 cos theta. They tell us that theta is an element from 0 to 360. When you get your trig function questions, they'll always give you a domain. Alright, the domain 0 to 360, y is equal to negative 4 cos theta. Now remember, whenever there's a number in front of your trig function, that affects the amplitude. Okay, what am I talking about? Let's draw it and let's have a look. Okay. So I just want to remind you what your normal cos function is going to look like. So your normal cos graph looks like that. This is from 0 to 360. We have a maximum of 1 at 0. We have the graph cutting the x-axis at 0 at 90 degrees, and then we've got the graph cutting at 270, cuts the x-axis at 270, and then we have the graph reaching a maximum of 1 at 360 again, and it's got a minimum of -1 when x is 180. Okay, so those are all the key points on your trig graph. Now what we've done is when we've taken your y is equal to cos theta and we've now put in an a in front of that. As I said to you, that affects the amplitude. So that affects the height of the graph depending on what the value of a is. Alright, so I'm going to show you how -4 is going to affect the graph of cos theta. But I want you to take these steps down. If you don't know how to use your calculator to work out this graph and to get your key points, please take these calculator steps down. Alright, so this is the calculator steps to get the function values of y is equal to. So this is the function y is equal to -4 cos theta. Okay, in your calculator you can't put in a theta for your function, you have to use an x. Alright, first thing you do is you start with, I'm going to actually put up the calculator and show you. You're going to start with the mode and set up button. Alright, so let's clear everything and let's get back to there. So the first thing you're going to do is you're going to press mode. We're looking for a table, so we hit 3 and you see an f of x is equal to comes up. So I want to write that step down, so you're going to go mode and we're going to choose mode 3, which is your table function. You'll then get a screen which says f of x is equal to. In the screen, you now type out your function. So you write in -4 cos, you're looking at a function of x, so you'll only be able to use x. Okay, so f of x is equal to -4 cos x. So let's have a look and let's do that. So f of x is equal to -4 cos. To get to the x, you use alpha x, alright, and that's equal to. Alright, there shouldn't be a g of x, you should just go straight to the start. When it says start, you're going to start, you put in your domain. So you start at 0 and you end at 360, which is where you're going to end your function anyway. The next thing it will ask you for, and I'll show you when we get back to the calculator, is the steps. This graph goes up in steps of 30 degrees. Okay, so every 30 degrees almost, you can think of it in terms of every 30 degrees, some sort of key thing happens to the graph. It goes up in steps of 30. Okay, so let me show you on the calculator. So we're going to start at 0 equals. We're going to end at 360, press equals, and it says steps. It's going to go up in steps of 30 degrees. All right. Now, guys, what you'll see on your screen and on your calculator if you're following at home is you have a column with all your x values and then you have a column with all of your y values. All right? You'll see that in the first column, when x is 0, the y value is -4. These are actual points. These are points that you will now use and plot on your function. Okay, so on your graph, on your axis, sorry. These are points that you will use to plot on your function. So you will have when x is 0, y is -4. Put a dot. Okay. We're going up in steps of 30. So you can see at 30 we've got -3,464, excuse me. But we don't have to put the decimal points in. We can go skip straight to 60 and we see when x is 60, y, f of x is -2. So then you plot that value. You then use your arrow keys, go down to see more. Alright. You see when x is 90, then y is 0. And you keep going down. At 120, y is 2, and so on and so on and so on. At 180, y is 4. You get all of your key points. Okay, so this is going to help us to sketch the graph. Okay, so very, very important. Get this table up. If you've got this table up and you know how to get this table on your Casio calculator, if you can get this table, you sorted. Okay, graphs are going to be easy. All you've got to do is simply plug in the function, plug in whatever you're looking for. And incidentally, it doesn't just work for trig functions, hey? It works for all of your graphs. So parabolas, whatever else you're sketching, you can put it into your calculator and get your key points that you need to sketch and you need to plot. Okay, so once you've got this calculator table up, you can plot your points and draw your function. All right, so let me show you how we draw this graph now. So we've got our axis drawn, and we want to see what happens when the value in front of the graph, in front of your function, turns to -4. What does it do to the function? This was our original graph. Okay, so this was the original y is equal to cos of theta. Now, what's going to happen with this graph? All right, so I have an axis here. We're going to say it goes, this is naught, right? So that's your origin. We're going to have a point at 60. We're going to have a point at 90, 180, and 270, and then we're going to go along, we're going to get 300, and then we're going to get 360 at the end. Okay, so I'm going to plot these and then points on my axis. This is going to be up to there, say that that's 2. All right, my graph is obviously not drawn to scale, so it's not completely accurate. And then at the bottom, we've got -2, and right at the bottom, we've got -4. Okay, why do I go up to -4? You saw from your calculator, or why do I go down to -4? From your calculator, your minimum was -4, and you also saw that your maximum was 4. So that's straight from the points that you get on the calculator. So when x was 0, we saw that the y value was 4. So we're going to put a dot there. Okay. When x was 60, we got a y value of 2. All right. Okay, I want to actually call up your calculator and show you the value. So when x is 0, sorry, we've got a y value of -4. So that's going to be at the bottom. When x was 60, you got a y value of -2. So there we go. X is 60, y is -2. X is 0, y is -4. So on my y-axis, when x is 0, I plot down -4. When x was 60, we had a y value of -2. And when x was 90, we had a y value of 0. All right, let's call the calculator up back again. So we're going down. When x was 90, we had a y value of 0. When x is 120, we then go back up and we start increasing now. We see that the y value is 2. So when x is 120, we've got a y value of 2. And when x was 180, if we go down the calculator, we see that the y value was 4. So our maximum when x is 180 was 4. All right. And then we'll come down again and we'll repeat the same pattern. Okay, so that literally, guys, is just reading straight from your calculator. So your graph's going to turn, come down, and turn again. So my graph is looking a bit squiffy, but you get the general idea. So your pattern, we're going to go down from -4 up to +4. We cut the x-axis here at 90 and at 270. We then have a minimum value again at 360 of -4. So if you now compare this, y is equal to -4 cos theta, to your original function of y is equal to cos theta, you can see that firstly 2 things have happened. The negative has now inverted your graph, all right? So your graph is now inverted, and because we times it by -4, your amplitude as well has changed. Okay, so we now have your highest point used to be 1, and now our highest point is 4. All right, so we're also going to have the amplitude changing. Okay, so therefore we can see that this -4, or the number in front of the cos theta, affects our amplitude, and then depending on the sign of it, you could be looking at a reflection, all right, on the x-axis. If it's negative, your graph is going to reflect. All right, I think this is a good point to check if any of you have any questions so far.
I think the first one is from Masilela Zandile Mabasa. Masa. She says, I didn't see those steps for the calculator. Can you please repeat them for me?
Yes, absolutely. Okay, guys, what I'm going to do is let's repeat the steps, but I'm also wanting, what I'm going to do is show you a different graph. Okay, so let's take another graph, do it from scratch again, and let's look at the steps. Okay, so let's go through that one more time. We're going to draw another graph. Let's take y is equal to 2 cos x. Alright, or let's change our function this time. Let's make it sine. Okay, so we'll have y is equal to 2 sine x. Okay, calculator steps. First thing we do, when you have your calculator, your mode is going to be on 1, alright, which is just computation. It's your normal method that you'll be using. We want to change it into table mode so that we can set up our function. So we choose mode 3. Immediately you see it comes up with f of x. In f of x we write down our function. So we'll say f of x is equal to 2 sine. And now we're going to put in x. So we should hit the alpha. And then the x, close your bracket, is equal to. Alright, I'm not sure why the g of x is coming in, but it won't affect anything. We're not going to put anything for g of x. Usually you'll go straight from f of x is equal to 2 sine x. Press your equal, it will ask you to start. We're going to start in the domain that they give you. So remember, they can say sketch the graph for any portion. So they could say from 90 to 360. They could say from 0 to 180. Okay, so you need to start from the starting point in the given domain in your question. Here I'm going to say we're going to go from 0 and we're going to go all the way up to 360. That's where we end. We're going to go up in steps of 30 degrees. Alright, and then once again your table comes up. So if you have a look, you'll see when x is 0, your y value is 0. When x is 30, your y value is 1, and you can go down the table and you'll see when x is 90, your y value is 2. Now if you remember your normal sine graph, when x is 90, your y value, your function value is 1. So you can see by now timesing this by a value of 2, this has now changed that highest point. So it's no longer 1, it's now 2. Alright, and you can simply go down your table and just read off the values and then plot your graph from those sets of values. Okay, if I draw this for you quickly, let's have a look at what it looks like. Okay, so it was from 0 to 360. We had y is equal to 2 sine x, so the maximum value is going to be 2. Your minimum value is going to be negative 2. Alright, and it's literally by reading your values off your table, you're going to get a function that looks as I have drawn it. This value here, that's going to be 180 and 0. At 90, we have a value of 2. And then at 0, you have a value of 0. At 30, you had a value of 1. These values I'm getting straight from the calculator, guys. At 210, you had a value of negative 1. And then at 270, we had a value of minus 2. And then at 360, we had a value of 0 again. Okay, so this minus 2 should come down there. And then the highest point there is 2. Okay, so this differs. If you had to draw your original graph, at 90, your graph would only go up to 1. Okay, so if you look at your original graph versus the function y is equal to 2 sine x, you can clearly see the effect of timesing this 2 or adding this 2 in front of the x, multiplying the function by a value of 2. All right, I think, Abraham, are we good on that side? Everyone's
We're
happy?
good. Just a quick one. What if you're not choosing a Casio calculator using Sharp?
Well, then you should get a Casio.
Okay, thank you very much.
No,
Natasha.
you can do it on other calculators, guys, but then you need to actually go to your, look at your manual and see what the steps are for your table function. It can be done on any smart calculator, like the Casio, any version of that. You can do it, but you need to go and learn your manual steps. Unfortunately, I don't know those steps in my head.
All right. Thank you very much, Natasha, for
Pleasure.
that one. And thanks to you, Mindsetters, for tuning in. Last words from me. Great hands. Know that nothing is impossible because the word itself says, I am possible. Thank you very much for tuning in. Peace.